everyone. Today we are going to dive into quantum computing. I'm Shubham from Pi Ventures. I lead deals here, and with me today is Sujoy, who's one of the co-founders at Quanfluence, where they're developing something very interesting. So Sujoy, question for you. How did you get into building this company?
Yeah, so I started my career in Texas Instruments long time back in the year 2000 and did semiconductors, which was very exciting. And 2012, four of us got out of TI, started a company doing semiconductor IP, which is deep tech, very high speed interface IP, out of India. And we exited that company in 2018. So me, Ravi, Bhiman, we were co-founders of that company as well. And after the exit, we started thinking, okay, what next? And that's when quantum took our fancy. We figured out we needed to get more of the physics, angles, etc. as well. So we got a couple of physicists come together as co-founders, very well-known professors in this country, and Aditi, who also does product for us. We started seeing what is in the quantum space.
Yeah, very interesting. But I think quantum is supposed to be this like science fiction thing, a pipe dream, where people have been talking about quantum for so many years. So what sort of made you choose this particular space, and within this space, how did you arrive at your current product?
Yes, so quantum is the pipe dream, which is why we started doing quantum. What we realized along the way is that, quantum computing is exciting for several things. One of the main things is, if you do classically, you have to do things one at a time, right? So to explore a large enough space, you go one, and it's an exponentially growing problem, an NP-hard problem as they call it in technical terms. So quantum had this promise saying, all the solutions are there at the same time and you get the answer instantaneously. So that's what got us excited. And what we realized is that it is a little bit away, but there are parts of it which still can be done today. Right? They call it quantum inspired or quantum like solutions. And there's a large problem space out there which could really benefit from these solutions. That's how we arrived at our current product. So what our current product does is that it explores a large solution space simultaneously and comes up with an optimized answer. It does not go through it one by one like classical computing. So as the problem size increases, the solutions are that much faster, that much more accurate as we go along.
So obviously, when you described this to me at the first time that we met, it seemed as if I could solve any breadth of problem that exists in the world. But obviously, as a startup, you have to sort of pick and choose your battles, which is also a reflection of where the state of the technology is. So currently, what all problem statements can you solve? What all industries can benefit from this solution?
Yeah, like you correctly put, everybody in the world wants to optimize something, right? You want to optimize how you invest your money. So it's a clear-cut problem statement. But we would like to reach industries where there is a large scope, right? Where there are lots of such problems. One of the industries would be finance. Because the finance guys are always trying to optimize something, starting from your portfolio to your risk management or logistics. Because logistics has so many optimization problems. Every time you can optimize something, think of the Swiggy Bangalore problem, right? So many restaurants, so many customers, so many delivery agents. If you can keep optimizing this in real time, you get a better and better solution, and you're saving cost, you're making the customer happier because you're getting the product out to them faster. So these kind of problems would be an amazingly good fit to our machine.
Now, one of the more interesting use cases when you described this to me was just optimizing for even nurses in hospitals, right? So any workforce optimization where you have a large enough workforce with enough variables and constraints is a prime candidate for using such a solution.
Exactly. So like the allied problem, the nurse problem. And what happens right today, when you try to do it classically, you're making guesses. You're cutting the problem down to a smaller size where the human element comes in. What I call the emotion comes in. And once the emotion comes in, you're probably not getting that perfect solution. What we do is we keep the emotion out of it. Make the variable space larger and larger. And you just brute force solve it. And you don't do it one at a time because that's the exponent. You have a machine which can just solve it all together and you get an answer. then you reinterpret the answer. So we keep that emotion out of it. We do it based on pure physics or pure science.
Great that you use the word physics, because the first time we met, you said we are building a time multiplex coherentizing machine. That's what the product is called. Can you go into a little more depth into what does it actually do? What's the science behind it? How does it actually constrain so many variable problem and solve it so quickly?
Yeah. So what we do is we build something called a cubo, which is a fairly well-known equation between variables. But our machine is unique where all variables are connected to all other variables. So we set this up, and if you look at it from the physics angle, it's large matrices which get multiplied together, and then there are non-linearities, and these non-linearities are something which we use light to do. Right? So the function of light and how you balance it out, all of that makes sure that you get these solutions very, very quickly and efficiently. So that's basically the science behind it. There's a lot of matrix multiplications and non-linearities which are introduced by light in our case.
How did you, coming from a semiconductor background, how did you sort of develop this hardware? Because this is hardware plus software layer on top. So how did you develop this hardware, and what sort of talent do you now have within the company to scale this product?
Yes. So when we started this company, like I said, Professor Anil Prabhakar was part of the founding team, and he was doing work on this back at IIT Madras, and we are incubated out of IIT Madras. So that's how the genesis of this solution started. And then it takes a lot of engineering effort to take that physics and that hardware and make it work correctly to a problem statement, put it in the right box, make it available on the cloud, make it API accessible. So we then added those kind of talents in the team, people who understand the software, people who can convert problems into these equations, and people who can put this solution out there on the cloud. So that's how the team grew. So the team is a very good mix. There are people with PhDs in physics who come in doing all of the physics parts. There are engineers who come in doing all the engineering.
So is this just in theory on paper, or have you already demonstrated your product in what context, and what do the next few months look like for the company?
We do have this product demonstrated. The demonstrations are getting better as we add more front-end layers to it, but the back-end works perfectly. We can already solve about 10,000 variables all connected. In the next 3 or 4 months, that number should go up to 20,000-25,000. The speed up will happen.
100,000 you feel will be the tipping point to solve the majority of the problems?
Yes, I think we start getting very good solutions at 20,000, 30,000 itself. But at 100,000, you're probably going to not have to do a lot of these guesstimates or estimates or problem breakdowns which people have to do today.
So obviously you said the genesis of this was that quantum is a pipe dream, and that's why you got into space. What is the overall global vision of the company? Does the Quanfluence product line stop here, or are there other thoughts that you have?
No, it definitely doesn't stop here. The final frontier is the photonic based quantum computer that we are building. It is a little down out into the future, as we all know. But coming next year also will be a very good qubit emulator. Up to 32 qubits you should be able to emulate on a hardware emulator. So that journey is mapped out like that, so that we go step by step. We believe it's happening, and it's happening very shortly.
Very impressive. I think I speak for the entire investment team at Pi Ventures that we've been blown away by not just the technical expertise, but the clarity of thinking that you and Ravi and Viman and others bring to the table. Obviously, very rarely do you get to work with second-time founders in deep tech spaces, and we look forward to building this company together with you.
Thanks to Pi Ventures, I mean, people taking a bet on this is what excites us. We spoke to quite a few investors before, and Pi Ventures was one of those who wanted to take this bet.
Yeah.
So why? What is your thinking behind this?
So I think we've had a very bullish view on quantum for the last couple of years. We've always felt that maybe it was not the right time because of the long gestation periods, but we are starting to see the market move in the positive direction, with founders trying to build solutions that can solve today's problems. We are starting to see founders building the quantum sensing space. We are also starting to see the quantum communications space with PQC and QKD coming up. So we feel that now in the next 3 to 5 years, the adoption of, I would say, quantum, apart from quantum hardware, is going to be phenomenal. And I think this ties back into our vision of backing deep tech founders such as yourself, who are building world-class products across quantum, AI, semiconductor, therapeutics, all out of India, trying to put India on the deep tech roadmap. And I'm hopeful that we will be one of the first companies to build a photonics quantum computer right out of India.
Definitely.